The following content has been provided by RWTH, Aachen University.
Let's talk a little bit about Swift. So Swift is the programming language that we will talk about, and it's actually a programming language designed from Apple. 2014 actually was the first time released. Okay, just put it there. Why does it? Okay. Okay. So historically, Swift is quite a new language. I'm still very loud. Was introduced at the WWDC 2014. Has anybody does not know what WWDC stands for? Who of you doesn't know what the term means? It's basically, I cannot recall actually, but it's the developer conference from Apple where they introduce new applications. So basically every time they introduce a new iOS or the macOS version, it's a conference in Cupertino for 1 week where they introduce this stuff. And you can actually see the talks online. So that's the announcement presentations, basically. We have a lot of technical talks afterwards where the engineers who develop the systems, you can ask them and they will give presentations on all of these things. And a lot of things, videos that I linked into the seminar works are basically talks from this conference, basically, that give you an overview, and they also have demo applications and everything. So what's introduced there and is highly influenced by C and Objective-C. So Objective-C was the actual programming language from Apple, which is 20 years old. Basically, it's an object-oriented extension of C. However, it has a lot of features which are not that modern anymore, and Apple wanted to create a simpler and more adaptable language, and they introduced Swift. They say for themselves it's very fast, safe. We'll see how safe it is. It has a lot of things that you wouldn't expect, and it's very expressive because you can do it for a lot of things. And it's actually open source. So if you want to see what's going on with the language, there's a gigantic GitHub project called Swift, and you can actually already have a look at the latest version of Swift. I think the alpha is already out from the new versions. So you can actually see what the changes will be. So that's actually an interesting move from Apple to put that open source and actually let the community help developing this language. And they want to actually put it not also on a Mac, on iOS, but also on other platforms. There are already compilers for web. So there's called the Swift web thing where you can write backends with using Swift and other languages as well. So Swift has a very simple syntax, so it's not that very overblown. It looks very similar to a scripting language, so it does not have a semicolon at the end of a line, and it has a lot of optional functions. It has not really a pointer operations. We'll talk about this a little bit more later. The keyword optionals helps you with this, because typically if you have a variable in Swift, it cannot be null, so it cannot be empty or something like that. And we'll talk about this later. It has type inference, so it has very, very strong type sets. So if you define something as a float, it will always be a float, and you cannot even assign an integer to that. As you will see, the compiler is really, really type safe. But it does type inference. If you say a variable and define a certain value, try to figure out what kind of type it is at the part. Yeah, so it's very type safe, as I already said. It protects his types very, very strongly. And it has automatic reference counts, so you don't have to think about deallocation and memory management. Usually, if you write a clear Swift program, you don't have to think about memory management at all in general. Let's say it like this. There are some cases where you have to think about these things, but usually if the first application will see, you will never deallocate an object or something like that. It has other very nice characteristics. For example, tuples are a nice extension that actually let you combine multiple variables in one data structure in a simple way without having to create an array or something. That it has generics, which is a very, very complex structure, but it's extremely powerful. So basically can cluster types into a certain generic and allow these to use. We'll talk about this only briefly because it's actually quite complicated and very advanced functionality. It was improved in iterations over array iterations, stuff like these. There's improvement in that. And what it does, and compared to other languages, it boosted up the usage of structures very, very strongly. So structures got a lot more powerful in Swift. So you can now create functions for structures. You can assign like initializer for structures. So structs are very concept that we will see a lot of things. So we are not always working with classes, but a lot of structures as well. And then you have the typical ones like map, filter, reduce, and all of these functionalities that you probably know from Java or other applications. And it has a very interesting and always advanced error handling method. So you can do the typical try-catch error that you probably know from Java and other languages, but you can handle, you can work with errors in very different ways, so they offer you multiple concepts of this. So the easiest way to start actually working with Swift and start to program Swift are playgrounds, and Philipp will introduce them later on. I will just show you that. It's basically a sample application where you can just write Swift code. So you don't have to create any project at all. You just say in Xcode, I want to have a Swift playground, and this is how it looks like. So you can just write code at the beginning. So this is the easiest way to start programming using Swift without having to think about, oh, I need to compile it for a certain for a certain device. I want to need a GUI to show something. I want to have or put something in console. You can just run it here, and Philipp will show you later on how it works. So this is basically the simple application. It will just do an import of a UI kit. This is one of the frameworks that is on macOS, on iOS devices, and you define a variable here, hello playground, and it just print the hello playground. The interesting about this playground is it compiles on runtime, while you're typing. So basically, you type something, and the system basically displays what it's currently doing. For example, here, this is the printout, and the variable currently has that value. So you can do operations, and it will immediately does what you're doing. Not entirely immediate, but without having to compile and look at your phone and these operations. You can also do a lot of advanced stuff with that. You don't only have to display text, but you can also render graphics using this thing in the preview mode. For example, you can create a sprite kit framework that I showed you before and the 2D graph engine in the playground, and it will show you all of these things at the same time without having to think about some classes and stuff. So one of the biggest difference if you come from Java of any applications, you don't have really types. So when you write a code, you don't have really a type of a variable. You just have two options of a variable. So the one is var, x, and you have let. These are the two basically types that you can define a variable. So you don't have any floats. At the back you have floats, but you don't write this. Basically what the compiler here is doing is saying, okay, this variable x should be 100, and the compiler then decides, okay, what is this? This is an integer, obviously. So I will count this as an integer. And here again, the let, I define this as pi, and then the compiler says, okay, this is a float or a double. Depends on the system, but usually it's a float. The difference between these two, the one is variables you can change in the code every time you want to do that, and the let is a constant. You can never change this. So you can define this constant, okay, say pi, and I want to change that. The compiler will immediately say, yeah, you cannot do that. So you basically have variables that are fixed and variables that are, variables in a way. So these are the main concepts. So this is, for example, what the playground will do. I will decide this thing. Let x equals to 1 and y equals 2. And here you can see you can update the y, but you cannot update the x. So this sounds a little bit weird if you see it the first time, but it has actually a lot of concepts that you will see over the time. Why, at which point you want to use let, and at which point you use var and these things. We will figure that out together. So, as I already talked about this a little bit before, and Swift does type inference. As I see here, if you define the 100 again, it is decided to be an integer. And you can never change that to anything else than an integer. This x will always be an integer. And if you assign something to that, it will say, okay, I want to cast it as an integer, but I cannot cast it as a float. So this is something that you probably are not familiar with if you come from a different language, because usually every other compiler could do that. Well, not this way, but the other way around. So every compiler you can actually say, okay, I want to have a number in there, and this is like a float or something. But in this case, you have to actually then convert it to a different set. So maybe this could be other compilers that automatically, so it could be downgraded to 99 and not 99.5. But in this case, you would have actively cast the variable into the different format. So it doesn't do that automatically. And again, this would work because now this is a double in a way. However, you can also decide on the beginning when you want to have a variable that should be a certain type, you can define this. For example, I want to have a variable, a string, and I can type this point and then put a string on there, and then I can assign a value. So you could also say, okay, this should be actually a float by putting the dot in there and put float in between that, so you can actually then decide, okay, I don't trust the compiler, I want to need this as a float, but I don't know if this value is actually a float or an integer, but I want to assign this variable, and then it does that for you. So here are the typical types that you have in Swift. You have ints, you have doubles. For example, if you want to add this will not work because the one thing, this is an integer and you cannot add a double to that. What you have to do is basically cast this into a double and then compile it. So it's very strongly typed in fields. What you will learn in a hard way, that this is sometimes a typical bug that you find in your applications. And this would also work because in this case, Okay, and then you can print this stuff, and you can also use like emojis as variables, which is actually sometimes helpful, sometimes not. So you really have to be careful about these things. We had some applications where students submitted their code, and they had everything as emojis. This is annoying. But sometimes it's actually quite easy. If you want to point out to a specific variable, this is actually quite helpful because at some point you can actually see emojis clearly from the text with a lot of variables, and sometimes if you have a good emoji that describes your variable, that's maybe better than to write this in the text. But don't overdo it, please. Okay, as I already said, these typical variables always have a value. So you don't have like something that you know from C++ or something. You don't have a null object. So you always have some kind of value. And because this has the benefit that you always can ensure that this value is valid, and the compiler can work with that. That helps you a little bit to understand. However, at some point you need you need a nil or null pointer to anything, because that's how we program at some point. And Apple introduced the concept of optionals. An optional can be either a variable, for example, in this case, this is an integer, or it could be nil. It can have these two states. So you actually add an additional state to a variable. So it can be either nil or some kind of value. And you define this by basically saying, by putting this question mark at the end of your variable. So you define this optional should be an int of optional. So now you can actually say, okay, this should be 3, but you can also say, okay, this should be nil. So with this case, you can actually then cast, make sure, or if you see this variable, the compiler knows, okay, this could be either nil, or this could be either. It's actually implemented by using some kind of struct in a way which has these two states, or it's actually a tuple. We'll talk about this later on. So the problem with this basically defines a new variable type. So this is not an integer with the additional option of being nil. This is a fully new type, and you actually have to convert these things. So basically what you have to do, you always have if you have an optional, you always have to unpack it before you can actually use the value, or ask, are you nil, or something like this, and this will then work up. So I already talked a little bit about tuple. Tuple is actually a nice construct that looks like an array, but isn't. In this case, a tuple can easily be defined by just putting a brackets on there and put a couple of variables in there. So this helps you to put a lot of variables together in one thing. What you here see, so we have a tuple. The first value is an integer, the second value is a double, third value is a string, and the fourth value is a Boolean. You can also put a tuple with a lot of objects in between like that. So you actually can combine variables together to create some kind of like temporary object that has actually the type. First object int, second object double, third object string, and fourth object should be a Boolean. And here you can actually define this as this one. And you can then say, okay, I want to access this variable by getting the second value of this. You always start with 0, and then you can get the hello after that. You can also change these things. However, you can only have to be type safe. So you couldn't put a number into this hello operation. So this is a way how you can actually then combine something. Or if you want to have a function that should return multiple values. For example, this is one way to do that by just returning a tuple with this different variables. And instead of just having create an array that allows you to restore it. And actually an array in Swift is basically one type of. So you don't have an array with a lot of different types, but here you can actually encode that. The problem with this doesn't really scale. So you cannot create, you could create a tuple with hundreds of different entries, but yeah, you would have to do it manually. So it's basically used for a couple of variables to combine these things. And actually the compiler helps you. For example, it doesn't know what it is, and it actually gives you these feedbacks, and you can actually see what the values are in there. And we'll show you also later on that you can actually name them. So a little bit about something that you are probably familiar with. A typical control flow, you have if statements, else statements. Yes?
Can we put a variable inside a tuple?
Yes. Yeah. From clear type. Yes. So control flow is the typical if, else, else, if. So this is the typical structure that you see. It also supports this short way that you can actually do in one line the if statement or the else statement. So nothing new here, very similar to these operations. So if statement is the same. However, switch statement got much more powerful because switch can do just not only one cases, but can also do like tuples. That's pretty nice because here you can actually say, okay, I have like a point. Let's say this is a two-dimensional point. And I want to have the case where I want to just check the origin. I can take the 0, 0, but I want to have something with the y value should be always 0. I don't care about the first one, so I can put this line in there, and it will always trigger if this is true, but I also can do the other way around. So you can have tuples, and the combination with switch statements are, especially for location on your screen, extremely helpful. And you can also use these in a combination with that. You can also define ranges. For example, if you have a switch case and you want to have like from value to 0 to 9, you don't have to write 9 switch cases and put them all together. But you can also say, okay, this case from 0 to 9 in my value should be this. I can just write it in this case and I get these different values. So switch statements is something that is usually not very often used in different languages, but here I used it much more often since I switched to Swift compared to Objective-C, because now I can do all these checks, which usually end up a lot of different if statements. But this is making it much more easier. Okay, so these are first impressions. We will dig into that detail tomorrow. And now Philipp will take over and explain a little bit about Xcode and how you can actually use it and how you create the first applications.
Okay, so let's start from scratch. So once I start Xcode, basically I have a lot of different options how I can create a new project. So to look at playgrounds first, let's create a new playground. And Xcode offers a lot of different templates that you can start from. So if I just have a blank one here, place it anywhere what you... I don't know, somewhere already exists, but replace. So, and as Simon said, we have a initial playground already set up. And I can have it running manually, so if I just execute a line, it will start that and show me on the right side, basically here now the value of the variable that I have. Or I can also set it to running automatically so that every time I write a line, then it will already automatically execute that. So, for example, if I just want to print out stuff, I can just print, get the code completion, and if I enter that variable here, it immediately shows you on the right what it would print out. So to go over what Simon introduced or spoke about, if we want to create a new constant, I just have to type in let x, for example, equals 1. Now I've created a constant that holds the value 1. And if I keep the Option key pressed, I can select that, and I can see that Xcode inferred that this is now of type integer. So without typing anything specifying that it should be an integer, this is what Xcode set up. Now if I try to adjust this, for example, give it the value 2, there I get then the error. Let's make this bigger. Because it's constant, I can't change it. But if you get a error or warning and it has this white dot in that, actually means that Xcode has a suggestion what you can do to fix that. So if I select that, you can see here, well, to change this or to fix it, you could make let into a var. So if I just press fix, it automatically adjusts it here, and the arrow should go away. And now I could assign that, and now X holds the value 2. But if I try to adjust it to, well, having a not integer value, then it will also complain. It will not automatically now infer, well, you wanted apparently to change it to the type from integer to double. It doesn't do that. It will complain about that. And there are a couple of ways how you could adjust this. So either you specifically here type that it should be of the type double, so having a colon and the type will change the value. So even though I've just typed in here 1, it will now be a double value, not an integer value. So if I look that up now, you can see that it's a double. Or I could cast it here to an integer or stuff like that, then it would actually, I think, round down or round correctly up. And that applies also to operations. So if I have now here y and z should be x divided by y, that will not work because 1 is an integer, y is seen as an integer, and I can't apply it because it doesn't know what should happen. And same here, if I would just cast it to a double, then it would work. And I can see here on the right actually what it's computed or what it ends up to. And yeah, similar for strings, I can just type ABC, and that would now create a string, and I can interact with that. So if I want to just append the next letter, I could do this or print it out. Or you just call a function on that string where I can then append another character or whatever I want. Now add the D to that. And now text does have ABCD in there. And that is also restrictive then to the types. If I want to print out the text and then say I want to have the results of our calculation in there, there the compiler will again complain because there are different types. And I could either cast this to a string to match that, or a more simpler way, if you want to combine strings and embed different parameters in there, you can, let me just change this. Use it by having the backslash and your value in parentheses. And that's one too much. So that will basically then execute or cast this into a string to print it out. So if I open our console, we can actually see what it printed out, having my ABCD, the comma, and then the value of the variable that we calculated here. So as Simon said, the Playgrounds is not limited to just these simple things. If I would create a new playground, one of the other options that we have is for a game. And let me just create that one. I have something else here. So, and there you can see it has a sprite kit game basically in there, and a lot of code that you can look at. But if I just open the system and let it run, it will start to compile that. And actually, we have here now this hello world, and if I click, I'm having these animations can drag across, and that is basically the code that is here now on the left, and you can take a look through that. So Playgrounds is very, very powerful for stuff like that, to test things out on a quick scale. If you have loops or want to see how often stuff is called, it will also list that. So it's quite an easy way to get an overview. But in general, if you want to develop something for a device, you're not done with a playground. You want a bigger project. So let's create one here. And there you also have the option for a lot of different platforms. You can type some or develop something for macOS, tvOS, watchOS, or for iOS. What will we be using most here? So and then you can set a name for your projects. Select the team that it's linked to. Well, let's do it for Simon's personal team. And set all the organization stuff. You have here selections, for example, for core data, because core data is something that requires a lot of setup. And if you already have a project and then want to use core data, that used to be very, very hard. Now it's a little bit simpler, but you still have the option to basically do all the setup already here. And for the language, you have the option to check whether you want to have it mainly developed in Swift or in Objective-C. You can mix them together in the end anyway. So we'll be using mostly Swift here in this lecture. So setting that up and create that. And that will create basically the whole construct or the whole app for you. Or do you have it a different one that works? No. What development profile would work for you here? The enterprise stuff. Maybe you have to sign in. Yeah, should be right. Anyways, so the Apple changed that a couple of years ago that you don't need to be enrolled in a development program, but instead, if you have your own device, you can develop for that with your personal team. That means you can deploy apps to your own device, but not to many more. Is it limited to, was it 5? Or really just your own device? I don't know. Yes, a couple. So this file that you see here, once you start, you have this Xcode project file that is selected now here. If I show that in Finder, does it open somewhere? Yes. It's also in the top level of your program. Gonna switch to the other one. Where is it? There we go. And in that file, you can basically set up your whole project, the details for that, whether it's running on both iPhone and iPad or just on an iPhone. Can set that up here, which orientations you allow for your app, and what frameworks you're using, external ones or by Apple provided. I'd say activate the different capabilities. If your app uses ClassKit, HealthKit, whatever, you can switch it on in here. There are other build settings that go a little bit more deeper into that, but it all is stored then in your Xcode project file. Yeah, if you want to copy different things or when you're deploying your app, can all be set up here. In general, the editor is split into 5 different areas. So you have your main window here in the center. If I select a code file, there's also where you would type your code. You have the toolbar up here on the top where you start building your app or running it or stopping that. And here you could select, if I would have different targets, different projects set up here, could toggle here between them, and then select the device I want to run it at. Since no device is connected here, I have all these simulator sizes that I can try out to test out my UI there and basically run things there. Then here on the right, you have a button where you can look for different code snippets or change the style of the editor. So this currently is the standard editor, but I can switch to an assistant editor that then shows two different types side by side. That's particularly important then if you design your UI, because it allows you to connect your code to your UI. But we'll have a look at that later on. The version editor, if you have version control for your project, this allows you to see the different timestamps or different commits of your project side by side and can see what changed over time. And these are just to switch the different elements you have in your scene. Here then on the left is the navigator, which shows all your files, has the storyboard, which is your UI, the product that you created, so if, the app bundle, so to say, in the end. Assets for different images, for example, that you can use throughout your project. Here in the bottom is the console, has both, on the left side you would see the variables. If you stop at a breakpoint, you can look at what are the current values of my variables at this point, can inspect that. And on the right, the console that prints out print commands or whatever you want to print out there. And on the right is I think it's called utility view, where you see context-sensitive information about what you're currently editing in your editor. So right now here, since I have the view controller Swift file open, it shows me where on the hard drive it is. And if I am setting up my UI, basically allows me to set the different properties of a button, for example. So if I just now let this run, it should already work. This now starts on a simulator for the iPhone XR. Let's see if it fits on the screen here. Always takes some time to set up. It's already here in the background. You can see you. And the simulator is basically allows you to use it like a normal phone. It's limited in a couple of ways, but the general setup in interaction all work. So since we have nothing in here, it doesn't show anything. But if I would swipe up, it should go back to, or is it maybe not started yet? Or maybe not. The problem if it doesn't show anything, I can't see if it's ready. Yeah, there we go. So, and you can also see the MacBook is heating up. So, yeah, it has everything on here, and you can test it out. Since it's emulating the device, of course, it is slower than the actual device. And stuff like the camera or proximity sensor that usually senses when you hold it up to your ear, all that would not work on here. So for that, I need to test then on a real device. Did it now crash? No, it did not. And doing the swipe motions on this on a trackpad is quite weird. But yeah. So what else do we have? And yeah, let's continue here. Like I said, there are different types where the compiler already tries to help you while you're coding. So if I just have something here, I want to deploy a constant, and I will say, well, I will never change that. At this point, the compiler already, maybe it's still a little bit too large, that you can't see anything. Presentation, still readable from the back. So and so. I would say what it says. So here it actually reminds me that, well, you've initialized a value, but you never used that. So this is the yellow thing is warning, which basically it does not prevent you from building and compiling everything. It's just tell you, well, there might be something that you should look at. So if I would try to adjust this, if I try to change a let constant, this is now then actually an error where I could not build it and run it at this point. So an error is something you have to take off. A warning you can ignore. You should probably not, but you could. So, and if I would, fix this to a that this is now a variable, then this error would go away, so I could build it again. And to get rid of the warning here that says to you, you've written to that, but you've never actually used it, you just changed the value of that. If I would just to print it out, then that would also go away. Actually, two handy shortcuts that you can immediately put to memory. If you press Command B, it builds the project, so you can see whether there are any compile errors, and Command R builds it and deploys it to the simulator or the device when you've selected that. So something else that Xcode helps you with is documentation. There's a lot of documentation how you use the different frameworks, how the whole system is running. And a quick overview, you can, if you want to, for example, see what view.load means. If you press the Option key, you can click on a method and it will give you a brief summary of the declaration of the method and what it is doing. And if you open the developer documentation, it has a lot more information on that and shows you where all this information is coming from and where you can set it up. And this documentation also holds a lot of information about the various frameworks and classes. So, for example, if I would look for SpriteKit, you can see there is a lot of information on this framework, how to get started with that, how to set it up. And for example, if I would go to MapKit here, very often there's also a programming guide. If I open this, this is then online. And it's basically a step-by-step instruction how to use that framework and provides a couple of demo code that you can use. So if you have the maps topic for your seminar, that's a good place to start. So we still have just a white screen. And like I said, the storyboard is where you set up your UI. And if I open this, get to this view. And that's essentially, what? Oh, yeah, the contrast on our projector is very good. Let me, is there now a, yes, there's a line around that. So this is what you can use to set up your UI. How does it? Do you have your gestures on here? No. Where's the zooming in here? Does it work? Oh, that one. Too easy. Too easy. So here on the left, you basically see the whole hierarchy of your elements in your view. Currently, I have only a view that is connected to my view controller. We'll get into the details about that later. But what I can do here, now where previously the snippets were shown, I now have my objects. And from the objects, I have a bunch of different elements that I can directly use in my UI. So for example, let's take out the label. And when I drag it around, you can see that sometimes these lines appear, help me arrange stuff. So if I have, can just change the text of that, have a label placed, And now I also want to have a button that I can place there. And so what I want to have, if I press that button, the label should change. So now, just from that, if I run that, we should see that UI. So here it is. But what you might notice, it's not the same as what I set up here. So this is actually now set up for an iPhone 8. And this is an iPhone XR, has a different dimension, different resolution. And this is now looking a little bit different. So what you don't want to do is set up your UI just for a specific device. And we'll talk about auto layout, which allows you to provide rules basically for the layout of your UI and that it adapts correctly to your different screen sizes that you have. So, but now, if I press the button here, I can see that the animation is there, but nothing happens. And they're actually where the assistant view comes in quite handy, because that here I can select the view controller, which is what is currently showing the UI here, or defining the layout. And I can connect my UI elements to code. So for the label, it's something I would like to change when I press the button. So I need a link that I can access the label from my code. If I just right-click and drag over to my code file, you can see that I have this line and shows that I can insert an outlet at this location. That basically opens this small window. I want to have an outlet and just give it a name as the text label. And if I connect that, it creates this code in my code file. So the element IB outlet, that specifies the type of connection that we have. Outlet meaning I can, from code, connect to my UI, that I can, for example, set the text of this label. Weak is something, the connection between the label here and the code, but we'll get into details about that later. Variable text label defines the name, and that I can adjust this. And the type is of UI label, but the exclamation point here shows that it's actually an optional UI label. But the exclamation mark means I can use it without having to unwrap it in my code. Still, it will break if this is not set up properly. So now for the button, it's actually the other way around what we want to have. So that I want to get notified in code when I press the button. For that, we want to have an action. So I could also set the button to be an outlet if I want to, for example, change the title or the text that is depicted on the button. I could have an outlet for that. But in this case, I want to get notified when the button is pressed. So I'll give it the name here. And I can say it for what events I want to get notified. Touch up inside, meaning if I'm pressing down the button and release while I'm still inside the button, then this would get caught. But there are a lot of different others that I can get notified from. So then if I do this, we now have here an IB action, which highlights to me, okay, this is something where the code will get called from the event in the UI. It's a function that's called button pressed, and about the syntax we'll get a little bit more details about tomorrow, but it's essentially the same as you would define a normal function then in Swift. And it has a variable sender, currently of type any, that is passed along to my function here. So in here, I could react to that button event. So just if I want to print out that the button was pressed, that would print out to the console the event. Or I could use the outlet we just created to access the text of my label. So if I want to get there, text label, and I want to change the text to, say, to this. And so if we let that now run, we'll compile everything. Now we have the UI here, and if I press on the button, it changes that. So the connection of elements to your code was then actually quite simple. And it's similar for other transitions as well. For example, if let's do that quick. If I just don't want to have one screen, but another one, so I just drag in a new view controller that I have, and just give it a text label so that we can see that. Another view controller. And if I want to say, okay, once I press the button, I actually want to transition now to a different screen, I can just right-click, drag to the new view controller and say that, well, yeah, it should show now this view controller, which adds this connection here, segue connection, that I could set up a little bit more. But even just from this, I have a transition from one view controller to the next. So if I do this, it changes to the other one without that I have to write any code. The way back doesn't work at this point, but we'll get to that in future lectures. And I think we'll continue with the other debugging information then tomorrow.
This content was provided by RWTH, Aachen University.